Yes, start.
So this is the second lecture where we will mainly deal with bases. I will discuss the homework questions first.
Yes, yes. First, how many of you did or solve the last class homework question? Please raise your hands.
Sir, who did solve or who didn't solve?
Who did solve, or at least tried to? Okay, great. Yes, now you may lower your hand. Sabyasachi, continue.
Okay, next slide. Next slide.
Yes, now start.
Okay, so numbers are represented by symbols called numeral. At this numeral system, the base refers to a number of unique digits, including 0, which is used to represent numbers. This system is a cycle of digits, which is used in this representation. For example, suppose we represent numbers in base 10, which is what we do generally. So the numbers used here are digits from 0 to 9. This pattern repeats after that. So after 0 to 9, you will again start with 10 to 19. The digits used are only 0 to 9. That's the all the digits we're using for base 10. That is 10 digits. Now base is also called as a radix. Now the ordinal numbers are represented in base 10, and so this representation contains 10 digits and it is shown. There's some other important base systems, like the binary base system, which uses the two digits 0 and 1, and hence it is called a binary representative system. Base 3 uses 3 digits, but base 4 uses 4 digits, and so on. A number can be written as A base B, where A is a number and B is a respective b's. And two numbers are not equal for different bases. Like 23 base 10 is not equal to 23 base 8. Any questions? Okay, next slide.
Does anyone have any doubt till this?
Sir, what that 23 with base 8, what that does that mean?
Actually, first it is read as 2 and 3. So suppose 2, 3 in base 10 is not equal to 2, 3 in base 8, because in base 8 you are representing it from 0 to 7 digits, and in base 10 you are representing using 0 to 9. So the value of the number 2, 3 in base 10 will not be equal to actually in 2, 3 in base 8. Like suppose in base 10 you go 0, then 1, then 2, then 3, then 4. Now suppose you're taking base 2. This is actually a cycle. So in base 2 you can use only 0 and 1. 0, then 1, then 1 0, then 1 1. So similarly the 1 0 of base 10 will not be equal to the 1 0 of base 2. You can see it, because the 1 0 of base 2 will represent the 2 of it's representing 2 of base 10.
Here,
Actually, they are not
and
equal.
23 base 10 is 27 base
It's
8.
actually just a
That
cycle.
is, you have to divide.
Yeah, 0 to 7. So you will go 0, 1, 2, 3, 4, 5, 6, 7. Then again the cycle will repeat. So that's
Yeah,
actually.
like I'm just telling how to convert 23 in base 10 to base 8. So first divide 23 by 8. What's
You
the
can see
question you
the
get? That's
converting
2.
now.
And the remainder is 7.
Converting is
So the
at.
first digit, second digit becomes 7. And then just divide 2 by 8. Here the remainder is 2. So converting this to base 8, it becomes 27. And we will just discuss this conversion later. Next slide.
Any doubt in this slide?
Can you show it for a second, sir? We are writing.
Okay, no problem.
What does 23 base 10 means? What is the value?
Could you repeat?
What is the value of 23 base 10? Or
23 base 10 is this no 23 base 10 is the normal system we use. So 23, and 23 in base 8 you will be learning how to convert into base 10, the system we use after next class, I think.
So, sir, what does means 23 base 8? Does it represent any specific number?
Yes, it represents a specific number. Base
Yeah,
is
that's not my question.
representation. Like normally we use base 10, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All the arithmetic operations or whatever we do in base 10. But similarly, we instead of using base 10, we can use base 8 as well, using digits only 0 to 7 to do all our tasks. Similarly, you can use only 7 digits. So that's just like this. And conversion of this base into this base you will learn next class.
Okay, next slide.
No further doubts? Okay, moving
Sir,
on.
just a minute, I'm just writing.
Okay, no problem.
We will share the screenshots later. Are you sure? Just move on for now.
No, let them write. We have enough time.
Sir,
Yes.
sir, if a number is written like 17 base 10, then what does it mean?
It depends on your base. 17 in base 10 is 17 in base 10. It's
So, sir,
no.
what number will it represent?
It depends on your base. It depends on your base. 17 in base 10 will represent 17 in base 10. There's no such meaning. It's just a representation.
Okay, sir. So, sir, what is the relation between 17 base 10 and 17 base 8 then?
That we will cover in next class, mostly conversion.
Okay, sir.
So moving on to the next slide. Sabyasachi.
Okay, so yeah, if you have to represent the number in base b, then you have to use the digits from 0 to b minus 1. Like for base 10, you're using 0 to 9.
And someone asked, what does the number represent? It actually represent this one. At this actually base 10 only, but you can still go through it.
Yeah. Okay, like for number representing n base b, then the coefficients from a0 to an that belongs to 0 to b minus 1. These are the digits possible. So this can be explained as a naught b naught plus a1 b1 plus plus an bn. Now, if you write a number n 10 base b, then this stands for bn, not 10. And some other bases than 10, then the digits is pronounced as a whole instead of as a whole. So, for example, suppose base 16. Base 16 uses the digits 0 to 9 and then the alphabets that we have to pronounce as word too. For the bases greater than 10, you need more digits than the customary 10 digits. So here we use the alphabets A, B, C, D, and so on. Base 16, that's the hexadecimal base. This is 0 to 9, and then A, B, C, D, E, F. Now the smallest base is base 2, which can be used to represent any number. This is the binary system. Now, if you have base 0, it represents 0 digits. Because, and without digits, we cannot represent number. So base 1 technically doesn't exist. Base 1 uses only one digit, that digit 0. So any number we write in this base, it will only become 0. Any doubts?
Sir, is that a and an minus 1, is that a number?
Which one?
So that written in an minus 1
Yes,
dot
yes,
dot dot
suppose
dot
that,
83.
that is just the different digits. Suppose you have a number in base b, an minus 1, that are just the digits. An is a digit, an minus 1 digit. So it's just a number in base b. So you ask now, what does this number mean? So it means this.
Oh, okay, sir. Okay, sir. I understand. Means like that is why we write 2 into 10 plus 3 for 23. So sir, that 10 it is written in base 10.
Yes, that is in base 10, but this is base b.
So sir, we have to write like, for example, if the number is 18, so sir, we have to write 2 into 8 plus 2. So
But
this will become in base 10, base 8.
18 in which base?
Sir, base 8. Sir, 18 in base 8.
Okay, 1 8 in base 8. So yes.
Okay, sir. So means we have to like the same thing which we expand the numbers while expanding.
Just showing, just a second. Suppose you have 1 8 in base 8. Okay. So now you just a second, my annotation is on. Just a second, my annotation is not. Sabbisachi, can you annotate an example? My annotation is not working actually. Just take an example and just demonstrate the formula.
Example of what?
This second one, a string of digits an minus 1. Take 18 in base 8 as an example.
Even for me, the annotation isn't working. It doesn't work.
Wait, I'm stopping just again and starting again.
Ayush, can you share again? Where did it go?
Yes, now it should work. So suppose you have 18 in base 8. You have 18 in base 8. So this number will actually symbolize what you have to do. Take is you have to take the last digit 8, multiply by 8 into 8 to the power 0 plus 1 into a to the power 1. Just like we do normally for the base 10. So this number will symbolize 8 into 1 plus 8. So that's 16 in base 10 or ordinary or in whatever system we use. So 16. This number will actually symbolize 16. Similarly, you can take other examples and do as well. So any other doubts for this slide?
Can you repeat what you said about 18 base 8?
Okay, suppose you have we have a number 18 and this is in base 8. So someone asks, what does this number mean in the base 10 or whatever system? So this number will in base 10 actually. So 18 in base 8 will symbolize 8. You have to take the last digit, multiply it with the lowest power of 8. 8 into 8 is 0. Then you move to the next digit 1. Then the next power of 8, it is a 1. Suppose you have 216 in base 7. You have 216 in base 7. So this number will symbolize 6 into 7 to the 0, then 1 into 7 to the 1, then 2 into 7 to the square. So that's actually the method.
Your annotation is not working properly.
Yes, yes. Any other doubts?
Can you explain the base part once more?
You mean this part?
Yeah.
So actually your base is just a cycle. Suppose in ordinary system, we use base 10. So base 10 means just which set of digits we use. So in base 10, we use the digits 0 to 9. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then our cycle ends. And then again we start. Then suppose it's 0, 1, 0, 2, 0, 3, 0, 9. Then our cycle ends. Then we again start 1 and again 0, 1, 0, 1, 1, 1, 2, 1, 3, 1, 6, 1, 9. Again our cycle ends. So we start from 2, 0. So 20, 21, 22, 23. This is the system we daily use in our all arithmetic and all. And now suppose you take another base. Suppose you take base 2. In base 2, you will have only digits 0 to 1. So the first number will be 0. Then your second number will be 1. Now the third number will be 1, 0. Then 1, 1. Now it again ended. So again 1, 0, 0. Then 1, 0, 1. Yes, so this is actually the base, but this 0, 1, then 1, 0. But this 1, 0 will not symbolize 10. This will actually, in base 10, it is 0, then it is 1, then 2. So this will actually symbolize 2. 2 in base 10. So as I said, then 2, 3 in base 10 will not be equal to 2, 3 in base 8. Any other doubts? Does anyone have doubts in the hexadecimal system?
No, sir.
Okay,
Okay, so next slide.
okay, there is a question based with the smallest useful base. Why? Does anyone know?
Sir, because base 2 means binary digits. So it is used in computer.
Why can't it be base 1 or base 0 as the smallest useful base?
Because you can represent in the other bases.
Base
Like for base 0, you can represent because it doesn't have no digits. And for base 1, it's only one digit 0. So any number you represent, it becomes just 0. So it's practically useless. But from base 2, that's a binary. You have two digits, 0 and 1, using which you can represent any number. So that's why it's the smallest useful base.
Now, Sabyasachi, continue.
Yeah, so this is a unique theorem of representing a number in a certain base. For any n greater than or equal to 1 and b greater than or equal to 2, you can uniquely represent n and base b using digits 0 a0 to ak such that these digits base b is equal to n, and each digit, that's ai, where I is from 0 to k, is less than or equal to b minus 1. Using this, you can represent any number in any base. Like for example, let's take base 10. So here, what's the value of k? 0 to 9. So ai belongs to 0 to 9. And this is less than b minus 1, which is 9. So it can write as just certain numbers, say 9, 8, 3 to 1, base 10. This is equal to n. And b has to be greater than 2. Like this means that it's a binary number. Before that, it can be represented like this.
It just says basically it just says that any number can be represented in any base for base greater than equal to 2. So any number in base 10 can be represented any other base. It just says this. Yes,
Okay, next
now
one.
we are moving to some special bases. This is the base 10. Our decimal number system, all our operations.
Sir, can you show the theorem once more?
Yes, there's nothing special about the theorem. Just say that it's just a fact that any number in base 10 can be represented in any other base, and that too uniquely.
Okay, next slide. Okay, so base 10 is also the decimal number system, which is generally used for normal arithmetic. It has the 10 digits, 0 to 9. And we always use these digits for counting. The only reason why this base seems natural is because we have been using this base for a long time. And in every civilization, this base math has been always been used. And one of the most probable simple reasons is the sea of 10 fingers. So that means that for them, it has to be useful in counting and it has to be simple. So that's why they chose base 10 to represent. Or before bases were invented, we normally started with base 10. Okay, next slide. And so for base 10, we start at 0, then 0 to 9, then again starts from 0 again, but add 1 on the left. Left with till 20, then starts with 2 again, 2 from the left, and that way. Or just next slide. Okay, so binary base 2. For this binary base 2, you have only two digits, 0 and 1, and it has to be used to represent any natural number. This base 2 is often used in computers and all other electronic computers. Like for in this base, you have start with 0, then 1, then again 1 again, but add 1 on the left and start with 0, so it becomes 10. Then again 11, then again start with 0 again, and add a number to the left. This number is already as 1, so I'll go back to 0. Add 1 is added to the next position. So after 100, again 1 is added to this position. Then this becomes 0, and here 1 is added. Then again this becomes 1, and then again all 3 becomes 0, and 1 is to the fourth position, and so on. This cycle goes on. So this is basically what happens in the binary based system. Any
Can
doubts?
anyone tell why we use base 2 in computers?
Yes, same question.
Because the mechanical
I
language
can.
uses only 0,
Because
1,
the
0, 1,
mechanical
0, 1.
language
Computer
consists only
only
0 and 1.
understands
0, 1, 0.
8 digits
plus and one.
No,
total.
actually, the electric pulses can only go in off or on switches.
Yes,
Now, off
exactly. You
switches
can
are
only go in the off
represented
and
as
on
0,
mode.
and on switches are represented
Yes,
as 1.
exactly. Yes. We are leaving this for now. You can just see this in the PPT we send later. It's not very useful. Yes, this is just an example. Sabyasachi.
So in the base tree, let's start with base tree. Here the base value was 3, and the set of digits as 0 to n minus 1. That's 3 months. That's 2. So 0, 1, and 2. Like for base 4, you have the digits 0, 1, 2, and 3. Base 5, it becomes 0 to 4, and so on. Like base 10, we already discussed. And for examples like this number in base 3, then you have the digits 1, 2, and 3. Like this number 210 1001.
2331, 3301, and these into 1729. At least the first two one to show them these all mean same 1729 in base 10. Hello.
Yes, can you hear me? So all these numbers, yeah, that's the Hardy Ramji number 1729, and these are all the representation of that number in different bases. Like 1729, when you represent in base 3, it becomes 2101001, and base 4 it becomes 123001. We will show the conversion later. And like we have said, we'll discuss in next class. Then we will show that how can you just convert each base and get 1729 in base 10. It's the next slide.
Show some conversion, like suppose, just a sec. Like, can anyone show how 2331 in base 9 is 1729 in base 10? Does anyone know?
Yes, yes, yes.
Yes, sure. You can annotate or you can just simply say it.
Annoting is enabled.
Yes, annotation is enabled, I think.
Yeah, it's enabled.
Anyone else?
Say it.
Kushagra, that is 21001 in base 3. That's base 3.
Okay, wait.
Sir, we had to represent 2331.
The first one, 2101001 in base 3 to base 10. You have to confirm it's 1729.
Okay, sir.
Now I have no more space, but I gave the explanation.
But why you are using 10 to the 5? Shouldn't it be 3 to the power 5?
Yes, sorry. Yes.
Yeah, so
3
basically,
to the power 5.
you just
Yes,
have to
one is,
you just have to check.
yes, I wrote it by mistake.
Yes, no problem. You just have to check the base. So 210101, it's base 3. So you will take the last digit 1 into 3 to the 0, then plus 0 into 3 to the 1. Similarly, take digit 2, you will add and you will get it to 1729. Similarly, for others, you can verify it yourself, and you for all the cases, you will get it as 1729. So does anyone have any problem converting or any other doubts still here?
No, sir.
Sabyasachi, continue. Sabyasachi.
Yeah. So first we will cover the binary numeral system. This is used in mainly electronic computers and base 2. The two 0 and 1 are represented using switches which is turned from on and off respectively. And it is used in most electric counters. Now, and the important base is the base 8, which is also known as an octal system. This is used occasionally computing. The 8 digits used here are from 0 to 7, and this represents 3 bits. That's 2 to the power 3.
Sabyasachi,
Then
wait.
decimal system.
Sabyasachi, do this in the next class. When we rejoin. Meeting is just ending, so I'm stopping. So please rejoin.
Yeah, so here we've been discussing the significance of some different bases. Like we covered the decimal system before this. Then the duodecimal system, that is the base 12. That is the numbers from 0 to 9 and A and B. And here it is generally used to express quantities in thousands and grosses. It's sometimes advocated due to the divisibility properties of 2, 3, 4, and 6. Now after this, another significant base is the base 16, which is the hexadecimal system. This is also used in computing as a more compact representation of the binary based system. Digits here are from 0 to 9 and then from A to F. Then is the 20 base, that is the vigesimal system. This is a traditional numeral system used in several cultures and still used often for counting. Then is the sexagesimal system, which is base 60. This was originally used in the Babylonian civilizations. Now today it is used in the circular coordinate system calculations, like and time measuring and degrees, minutes, and seconds, and is an analogy to the rotation of the Earth. Next slide.
Basically, you can just go through this. These are the different uses of all the bases. Yes, these are just add to your knowledge. You can go through them later when we send the slides. Yes, now the conversion. Sabyasachi.
So converting from different bases or converting between different number bases is basically a simple process, but often it might seem confusing. So we are going to divide this conversion into three parts. First part is we are going to convert from any base to the decimal base. Then the second part is from decimal base to any base. Then finally we will discuss for any base to any other base. Next slide.
So the first one we actually covered in the second slide, but we are still repeating. The first one is from any other base to decimal number base. So any base to the base 10. Sabyasachi, continue.
Like for example, let us take this number. Let us CN20. Then the number of digits are say n plus 1 digits. And F is in base B. And now we want to convert it to base 10 with n plus 1 digits. Then it can be represented in base 10 in this way. Summation from k equal to 0 to n, ck bk. That is c naught b naught plus c1 b1 plus dot
Sabyasachi,
dot dot
take
plus cn bn. The formula we discussed in a few slides before. It's the same thing here.
Sabyasachi, take an example and explain. This may seem confusing.
Okay, so what examples can I take?
Take 4231 in base 5.
Base 5, suppose we are converting these to base 10. So what's the first digit? First digit is 4. And the summation formula. So 4, this, okay, as in base 5 first. And we have to convert this to base 10. So its position here is 3. So 5 to the power 3 plus 2 into 5 square plus 3 into 5 plus 1 into 5 to the power 0. So this becomes 125 into 4. That's 500 plus 25, 50 plus 15 plus 1. That's 566. Let us take another example.
Suppose, yeah, just a second. So basically, whenever you have suppose 4, just a second. So whenever you have been given a number, suppose here you have 14231 in base, you have base 5. Now you have to convert into base 10. So number it according from the nearest digit. So number it 0, 1, 2, and 3. So now this is 0. So you take 1 into, you multiply it with 5 to the power 0. Then add it with 3 into 5 to the power 1. Then 2 into 5 to the power 2. Then plus 4 into 5 to the 3. Now you add them, you get the number in base 10. So any problem in this
Can you
conversion?
repeat?
Here, just a second. Yes, suppose you have any number. Suppose here we are having 4, 2, 3, 1, and the base is given. This is in base 5. Now we have been given to convert in base 10. So whenever we have to convert in base 10, so you take this 4, 2, 3, 1 and you number it accordingly from 0, 0, then 1, then 2, then 3. Now you take 1 into 5 to the power 0, then 3 into 5 to the power 1.
I got it.
Yes, so similarly add them. So any confusion in this conversion from any base to base 10? Okay, so let's move to some problem. So I'm just giving a random questions, just a second. The first one is 2, 3, 6, 1 from base 7 to base 10. Then the second one is 1, 2, 0, 0, 1 from base 3 to base 10. And the third question is 568, 568 from base 9 to base 10. Solve this question.
All to base 10. All to base
Yes,
10.
all to base 10.
Could anyone solve? How are you approaching?
Sir, I solved the first one.
Okay, so what did it do?
Sir, it is given 2361 in base 7. So it is becoming 1 into 7 to the power 0 plus 6 into 7 to the
It's
power
also
1 plus
8750. It's also 8750.
And what's the final
yes,
answer?
sir, 870. Sir, 876 to the base 10.
Yes.
Yes, correct.
And the other ones? What did it do for the second one? It's also fairly simple. Okay, I'm
The
telling for
second
this
answer
one.
136.
The base
Sir, 136 to base 10.
It's 136.
Yes, correct.
Here I'm showing how. It's 12001 and base 3, which you have to convert here. So you can write this as 1 into 3 to the power 4 plus
Sachi,
2
let them
into
solve the
3 cube.
question then explain. Sabyasachi, let them solve all because some of them haven't even solved the first one, I think.
It's basically the same process for everyone.
Sir, for 568 to base 9, will it be 467 to base 10?
568
Yes, sir.
Just
to
a
n base 9.
Yes, sir.
check. I haven't solved this. Just a second.
Yeah, it's 467. It's 5 into 9 square plus 6 into 9 plus 8 into 9 plus 0. That's 45 into 9 plus
Yes,
54
correct.
plus 0. Yeah. 467.
So if you were able to solve these three
Okay, so next
questions,
slide.
please raise your hand. Or if you're still solving, but you will be able to solve, like you know the process. So it's still just 1, 2, 3, 4, 4, and so others. So shall I explain how to solve, or you will be able to solve?
Can you explain, sir?
Yes, explaining. So the first one is 2, 3. First one is 2, 3, 6, 1. First one is 2, 3, 6, 1 in base 7 to base 10. So whenever we have to convert in base 10, so I told you to simply write 0, 1, 2, and 3. So now take 1 into 7 to the power 0. So 1 into 7 to the power 0 is 1 only, 1 into 1. Then you take the next digit 6, and the number above it is 1. So you multiply it with the first power of 7, 7 to the power 1, which is 7. Then you add it with the third digit, third. So the third digit, the power above it is 2. So 3 into 49. 7 square is 49. 49. Then similarly for the last you do 2 into 7 cube. Similarly you add this, you'll get the answer. Similarly for the second one you have 1. The second one you have 1, 2, 0, 0, 1 to 1 in base 3. Just a second. Just a second. Yes, the next one you have 1, 2, 0, 0, 1 in base 3 to base 10. So similarly 1 into 3 to the power 0, which is 3. Sorry, 1. 1 into the 3 to the power 0 is 1 into 1, 1. Then 0 into 3 to the power 1, which is 0. Then 0 into 3 to the power 2, which is again 0. Then 2 into 3, 0, 1, 2, 2 into 3 cube. 3 cube is 27 into 2, 54. 54. Similarly, for the last 1 into 3 to the power 4, so plus 81. So add it, you will get the answer for this one. And the last one is 5, 6, 8. 5, 6, 8 in base 9 to base 10. You have to convert 8 into 9, 8 into 9 to the power 0, that is 8. Then 6 into 9 to the power 1. Similarly 5 into 9 square. So you'll add them and get the answer. So any problem in this conversion? Anyone?
No, sir.
So just basically if you have to convert in base 10, you just write 0, 1, 2, 2, and for the succeeding powers, you just multiply them. For the succeeding digit, multiply with the succeeding powers of the base. So there's a question first. Uh, yes, try to solve this question.
Is it 248? I think it should be. Ayush, is the answer 248?
I will have to check just a second. Give them 5 minutes to solve first. Yes, if anyone's answer come, the answer is 248. So if anyone answer come 248, please tell.
Okay, so who else solved? How did they approach?
I mean, I'm solving late. for-
Did anyone else solve? Just respond at once.
Suggest a minute.
No problem. You have enough time.
Others, everyone isn't responding. We have 12 people here.
Sir, I got two equations, sir. Z plus 7y plus 49x and its reverse is z plus 9y plus
Yes,
89.
yes. Now manipulate them to try to get
Now the
something.
equations have to be equal. So we'll get b equal to 8 3a minus 5c.
You don't tell right now. I'm pausing screen share for a while.
Sir, I couldn't understand the question. Could you please explain me?
Yes, I'm explaining.
Sir,
So
like what does that mean? Actually, just I wanted to know.
several three digits in base 7. So suppose you have A, B, C in base 7. You
Is
have
equal to
number
cba
A,
in base
B,
9.
C in base 7.
And we have
This
to
is
find the number
actually
in base 10.
this is equal to C, B, A in base 9. It just
Okay.
means this.
Okay, sir. Okay, sir. I understand.
You just have to
So just
find the
convert the
number.
first and convert the other one and then equate them. And from what you get, just convert it to base 10. And that's the answer.
So just a second. ABC in base 7 equal to CBA in base 9. So you cannot do anything actually right now because one is in base 7 and one is in base 9. You cannot compare, do any operations like adding apples and bananas.
You're supposed
You
to
cannot
convert
do
this to
anything.
base 10
So
and this to base 10 as well.
So we have to
So
convert into base 10, right?
convert them
Yeah.
into common base, preferably base 10. So convert
So like
them
this
into
is
base
the
10.
fourth digit, this is the first, this is the second digit. Just number it like this. 210. So a into 7 square plus b in. Okay, I'll solve later. I'm giving some more time.
I got it. I got it.
So I took it like this. I took it like 100A plus 10B plus C is
Yes, yes.
equal
Now
to 100.
equate them and then manipulate them.
Sir, after equating them, I'm getting 24x minus y minus 40z.
Could you repeat?
After equating those both, sir, I'm getting 24x minus y minus 40z.
you will get 24a minus 40c equal to b.
Yes,
From
yes.
that, just get the value of b.
Yes, sir. Same, sir.
Equate them and try to analyze the equations you get.
I got the whole answer.
What did you
Why
get?
do this annotation?
So
Okay, never
from that,
annotation.
from the equation Gagan said, we get b is equal to 8 into 3a minus 5c. From here, we can have two cases. 8 b is equal to 8 and b is equal to 0.
Yes,
If
right.
b is equal to 0, then a is equal to 5 and c is equal to 3. And if b is equal to 8, then because a, b, c are in base 7 also, then their maximum value cannot exceed 6. Therefore, a, b, c will be 5, 0, and 3 respectively,
Yes, yes,
which we,
yes,
if convert into base 10, we will get 248.
yes, correct. Absolutely correct.
So can I just solve right now? Or will I wait for some more
I
time?
won't be able
He
to
told
answer it
the whole
actually.
process. He told the whole process.
Okay, so I'm telling again.
Did anyone else solve?
Why did this stop the recording? Never annotation. The
Sir,
annotation disable.
So now I think Sabyasachi continue with the solution.
Just go back to the previous slide.
Go back to which slide?
The previous one.
The question is in this one, but
Yeah. Just remove the solution here.
can now continue.
So like we assume, this number in base 7, A, B, C, base 7, it gets reversed in order. So C, B, A, base 9. We can write this right, as we saw before. Now first we have to convert this to a certain equal base. And from that equal base, we are going to just manipulate. This is the 0th digit, first, second digit. 0th, first, second. So first convert this to base 10. So what will I get? A into 7 square plus B, where's the square? Into 7 to the power 1 plus C into 7 to the power 0. So that becomes 49A plus 7B plus C.
Are you to
And
started
similarly,
recording now?
No, the recording was on whole time. I just by mistake I pressed stop recording for once. Then I
Okay.
resumed. Just
yeah, for this one, you will get 9 square into C, which is 81C plus 9B plus A. Now these two are equal. So 49A plus 7B plus C equal to 81C plus 9B plus A. That's this A, just a minute, this A and this 49A, this becomes 48A equal to, that's 9B minus 7B, that's 2B plus 80C, or 24A equal to B plus 40C. Now first let's get this in terms of B. B equal to 24A minus 40C. If you take 8 common, so it becomes 3A minus 5C. Now what's the maximum value of the digits? For A, B and C, each of them cannot exceed 9 in value. So B here can have two values. So either B equal to 8 or B equal to 0. If B is 0, then this thing is 0. So 3A equal to 5C. So this is one case. For here, the only value is A equal to 5 and B equal to 3. Did you understand it? Then here. A is 5 and B is 3. And C is 3 when B is 0. And when B is 8, then, so, okay. Will I write again?
no, you just explain. I will share the presentation solution as well. Sabyasachi,
Okay, so in both cases, we get the only one solution set. The sound eating again. like we saw, 5a equals to 3c. So a is 5, c is 3, b is 0. This is one of the solutions that's possible. And so for this becomes 503 in base 7. Now this converting to base 10, it becomes 248. This is the one of the first answer. And for the second answer, you have to just take cases and assume.
No, there won't be a
And
second
someone wrote the other answer in chat.
In the second case, the value will be not in base 9. So
Yes,
base 7 here, we have to
exactly.
reject it.
Yeah, the digits are in both base 7 and base 9. So digits have to be from 0 to 6.
Yeah, so if b cannot be equal to 8, so we have to
Eliminate.
reject it.
This is the presentation solution. Just go through it. If you have any problem, please ask. Just a second, in CBA in base 9 equal to C into 9 square. Sorry, the 9 is present as a subscript, but it will be actually the superscript.
Sir, I have understood.
Anyone has any doubt?
Sir, I understood.
So we will share the solution later as well. If you have, so if there is any problem, ask. Then we are moving to the next part. So I assume no problems are there. Now the second part of the conversion from decimal from base 10 to any other base. Sabyasachi, continue. Take an example and explain.
So now we are basically discussing how will you convert a number in the decimal base 10 to any other base. Like these are some of the steps. I'm going to explain all the steps in detail. For example, suppose this number, say 15. Okay, so you have to convert this to some other base. Let's assume we'll see the base later. Suppose base b, 15 we are converting to base b. So first we have to divide this decimal number 15 by this new number, this number base b, and know the first remainder. Like I'm taking another example, just wait. Like let us take a better number. Wasn't the annotation clearing? Okay, so convert 56.
Take from base 10 to base 2.
Let's convert 56 from base 10 to base 8. Base 10 to base 8.
Okay.
So first step, divide by this number, base 8, so divide by 8. So what do we get? The quotient is 7 and the remainder is 0. So the first digit, this number I showed, is the 0, this is the first digit, so this becomes 0. And for the second case, with the quotient obtained in the previous case, like where we got 7, by the new base b again and know the remainder. So when you divide 7 by 8, the remainder is 7, so number just becomes 70. So 56 in base 8 is just 70. Did you understand? Anyone say something?
Sir, I couldn't. Could you please
Yes,
repeat?
I'm explaining again. Just a second. So suppose you have a example. Let's take just a second. Annotation. I'm taking a small example. Suppose you have 21 in base 10. You have to convert into base 2. So whatever number base is, so this method is from base 10 to any other base. So here we have 21 in base 10. We have 21 in base 10 to base 2. So you write 21, and we will do repeated division. We'll divide again and again by in the base we have to convert. So we have to convert in base 2 here actually. So take 2, divide it by 2. So it will become your just a second. 2 into 10, 20, and the remainder here is 1. Similarly, 2, just a second. Just a second, my annotation is stopping. Yes, now 2 into 5, and the remainder here is 0. Then again 2 into 2, 4. The remainder here is 1. Then 2 into 1. The remainder is here is 0. Then you will have to stop till you get the remainder as 1. Now what you have to do, just go backwards like this. Write 1, then 0, then 1, then 0, then 1. This is the number in base 2. Any confusion in this?
Sir, how did you find out which number is in base 2? Like, what is
I told
the
you,
number?
you take the number 21 in base 10. You have to convert it. You have to convert it into base 2. So you divide it by 2 and again. So note the quotient here. So 2 divided by 21 gives quotient 10, and the remainder it gives is 1. So note down the remainder. Then again divide the new quotient as the by 2. 2 divided by 10 gives 5 as the quotient, and remainder 0. Then again divide 5 by 2, so it's give 2 as quotient, 1 as remainder. Go till you reach the quotient as 1. So now the quotient is 1. So now just go in backward, write the quotient 1, then write the remainders in backward. So 1, then 0, then 1, then 0, then 1. This will be the number in base 2. I'm taking another example.
Sir, what did the number come?
So
Let me show
I
one
just
in some higher base. Like suppose base is base 16. Will I show that?
yes, I'm
Like okay,
continuing.
I'm
Just
showing.
a second, Sabyasachi.
No,
Uh,
let me take an example
I'm
first.
taking another example.
Take this number 187.
Sabyasachi, I'm taking
Okay,
an example.
after this.
Okay.
So this number 187 in base. Okay, 187 in base 10. Convert this to base 16. What is this notation so irritating? Just wait. Is it clear now? Base 10, base 16. Is the annotation clear now? I just tell this first.
Yeah.
Yeah, now it is.
So first,
Sir, that
you have to
example, sir.
divide this by the base number. Guess what?
Sir, in that question, I just wanted to verify that was the number 101.
Yeah.
Which one? The 21?
Okay. Yes,
Yeah,
sir.
it's
Yes, sir.
101. So first
No,
step,
just
you have to divide by the base number. So divide
no. I don't think it will be
187
21.
by 16. So now what's the question? Question is
Sabyasachi,
11
don't take base
and
16.
the digit remainder you go to 0.
Sabyasachi, don't take base 16. Take a base smaller than 10.
Okay, I just wait. Okay, base 9. 187 base 10 to
101.
base 9. So first you have to divide 187 by 9. That's divided by the base number. So when you get divide 187 by 9,
You
can I
mean
just share? I will
ending
just
or
stop the share of
starting
this
again?
first.
Sabyasachi, do this in next one.
Just wait, I can complete this.
Okay, no problem. I explained that in the previous one as well. The question is 7 to 6 in base 10 to base 8.
Is it 1326?
Let me check. I haven't done as well.
Where is it? 1326.
Yes,
I
sir.
guess it's
Yes,
1326.
1326. Yes, 1326.
Yes.
Okay, sir.
So do you have problem solving it, or shall I explain the how to solve this one?
I got a zero in between. Like I got 1306. So
How did you get 13206? Just
13026.
I think it will be 1326 only.
Sir, I also got a 1326.
Sir, are there any more questions?
I think there's one or two.
Okay, sir.
Ayush, did you solve yes, last day's homework problem? That challenge one?
Actually, I have a class from 5:30, so I will have to leave. So I will just explain this problem. I will post a written solution in the doubts channel. I'll send it. If they have any problem, they can ask in the next class. Actually, I have a class from 5:30. So I'm moving on.
Please raise any of you solved it. That challenge problem.
Sir, that Ramanujan series problem.
Yes, that 1 plus 2. I think only Sukrit sent the solution.
I tried the solution before the class, but when I asked Shaukarya Bhaiya, he said the time is up.
Okay. So I will send.
For that question, did we have to take like we had to prove it is equal to 3 by taking it root 1 plus 9 like that, or we had to show it?
You have to show it.
You simply had to observe a
You
pattern.
have to go.
Not a pattern.
You cannot backtrack here. You have to show the method using that the radicals.
I couldn't do that. Actually.
Okay.
Can you show the answer right now?
Actually, I have to leave. I will send the solution later in the channel. I'll just explain this, then I'll conclude the meeting.
Yeah, okay.
Okay, for this 7 to 6 in base 8, so what you have to take, you have 7 to 6 in base 10, you have to convert it into base 8. So you'll divide it by 8, you'll get is 90 as quotient, 98 is the 90 into 8, 720, and 6, you'll get 6 as the remainder. Now again divide by 8, so 8 11s are 8 into 11, uh, uh, 88, then remainder as 2. The remainder has to be actually less than less than 8. So then 11 divided by 8. Which will give 1 as quotient, the remainder as 3. Now this 1 is less than 8. So now just go 1, then 3, then 1,
1, 3, 2, 6.
2, 6, just like this. Just a second, moving to the presentation. This and yes, this is from any base to base. This is just the last one, any base to any base. So suppose you have to convert base 2 into base 3. Suppose you have base 2 into base, you have to convert base 2 into base 3. Oof, what is that? Yes, so suppose you have to convert base 2 into base 3. So what you have to do, convert base 2 to base 10 using the method taught, then convert base 10 to base 3. So in this way, you can convert any base to any other base.
Okay.
Okay, so I
So
will.
means we have to take common. We have to take common base.
No, it's not common base. Here you are asked to convert.
No, to 10, to 10. Sorry, to 10, to 10.
Yes, you have to convert 2 times. So this was the last. So operation will be done the next class. So this will be a homework. I will post in the group as well the presentation. All these will the convert question 2 will be a homework. The whole question 2. This
We won't be joining, right?
could you repeat?
We will not rejoin, right? It's done for
No,
today.
I'm ending the meeting. So this will be the homework. Just take a screenshot.
We will send the PDF. Okay.
Yes.
Sir, the class is finished.
Yes.
I will also send that homework challenge problem.
Yes, I will send it. So I'm ending the meeting.